Welcome to this explainer. Today, we're embarking on an epic journey into the formidable reality of industrial robotics. You see, this isn't just a story about metal and code, it's a complex, high-stakes narrative of engineering, economics, and international law.
Look at the machine, a literal marvel of modern engineering. But what does it truly take to build, protect, and export a robot? Well, it's a journey completely fraught with hidden costs, strict biological thresholds, and unyielding international laws that read more like a high-stakes technological thriller. Let's unravel the truth, layer by layer, before the final answers unfold.
Okay, let's dive right into this. Every single robot, from a domestic helper to a factory titan, is born from a biomimetic trinity known as the Sense, Think, Act loop. It senses its environment through a vast array of cameras, LiDAR, and force sensors. It thinks by processing those inputs through advanced software, often utilizing real-time operating systems on a central controller. And then it acts by driving high-performance mechanical actuators like brushless DC motors. This is the living anatomy of automation. Sensors, software, motors. The rule of three that brings cold metal to life.
Act 1. The Anatomy and the Hidden Cost. We're discovering the shocking financial reality of the factory floor.
So you think the robot arm is your biggest expense? Actually, think again. A heavy-duty robotic arm, let's say the standard Bots Thor model, which is capable of a massive 30-kilogram payload, might start at $49,500. But I have to tell you, that price tag is a complete illusion. To deploy a fully integrated robotic cell, you have to apply the industry's rule of three. The arm itself is merely 1/3 of the total cost. Integration, custom programming, and software, that makes up the next third. And safety barriers, end-of-arm tooling, and part presentation take the final slice. That $50,000 arm suddenly demands a true upfront investment of $150,000 to $300,000.
And honestly, capital is only your very first hurdle. The very heartbeat of the robot, its motor drivers, its power management integrated circuits, its precision sensors, is bound to an absolutely terrifying global supply chain bottleneck. Manufacturers right now are staring down lead times of 26 to 52 weeks just to secure these critical semiconductor components. I mean, imagine that for a second. An entire year of just waiting before the very first gear even has a chance to turn.
Act 2. The Armor. Navigating the global safety shield and biomechanical thresholds required to protect human life on the factory floor.
And this brilliantly illustrates how an overlapping triad of acronyms forms a strict legal barrier you absolutely must conquer before deploying a single machine. First, we have the newly updated ISO 10218, Parts 1 and 2 for 2025, which completely dictate global design and integration safety. Then, there's the American ANSI/A3 R15.06 standard focusing heavily on the end user's actual day-to-day use of the cell. And finally, the CE Machinery Directive. This isn't just a marketing logo you slap on a box, it's an absolute legal requirement for entry into the European market, demanding rigorous risk assessments. You simply must penetrate this armor of compliance, or your robot will never legally operate, no way around it.
So how do we actually, legally, share space with these incredibly powerful machines? Well, the standards define 4 collaborative operation modes. First, monitored standstill, where the robot simply freezes if a human enters the zone. Then, hand guiding, for physical teaching. Third is speed and separation monitoring, where safety-rated lasers dictate the robot's pace based entirely on human proximity. But the fourth mode, power and force limiting, is where the reality turns a bit dark. It literally relies on actual human pain onset thresholds. The machine is legally allowed to make physical contact with a human, but its force is strictly limited by intense biomechanical research, so it only causes pain, acting as a warning rather than causing a severe injury.
Now, what's really interesting about this slide is a dramatic plot twist. Just listen to the words of Todd Dickey, the chair of the R15.06 Safety Subcommittee. There is no such thing as a cobot. Rather, there are robots that utilize collaborative technologies. This completely shatters a major industry myth. You cannot just buy safety in a box. A force-limited arm holding a sharp welding torch, that's a deadly weapon, not a friendly collaborative partner. Compliance is purely a property of your specific application, your tooling, and your unique workspace.
Let's move to and see how this builds into Act 3, the arena. Entering the strict global battleground of dual-use export controls and international law.
I have to ask you, could your simple morning email accidentally trigger an international arms export violation? Well, the answer is a resounding yes, and it's because of what the law calls deemed exports. It's not just about physically shipping a massive robot across a border. Intangible transfers, like sharing proprietary software, sending technical drawings over email, or even just granting a foreign national access to your research facility, are heavily regulated because these are dual-use goods, meaning they have both peaceful civilian uses and potential military, nuclear, or missile-related applications.
So the crucial point is this. Failing to secure a dual-use export license, like the SCOMET license in India or the EAR in the US, carries severe, life-altering penalties. We're talking about absolutely massive monetary fines, total confiscation of your expensive goods, the complete suspension of your export privileges, which would cripple your business overnight, and in serious cases, actual criminal prosecution and imprisonment. This is the ultimate, unforgiving arena of international trade law.
As we conclude this explainer, I want to leave you with a final, profound question to consider. Look closely at your supply chain. Look at your engineering data. Look at the software running your machine right now. Are you simply building a manufacturing tool, or are you deploying an internationally controlled weapon? The line is far thinner than you think, and the stakes have never, ever been higher. Keep learning, keep analyzing, and ensure that your leap into automation is as safe and compliant as it is revolutionary.